All right, so we were doing some factoring last time. Let's just pick it up from where we left off. I'm trying to find some interesting questions here. Look at question 16. What do you notice about all of these questions? There's 6 of them, A to F. What's the trend? Do you see anything? Notice how the degree just means the maximum power. What's the degree for all of these? What's the power? What's the number in
2.
the exponent? So they're all 2's. Okay, degree just means the power, which means it's a quadratic. How many terms are there?
3.
3. So we have a quadratic trinomial. How do you factor a quadratic trinomial?
You use man.
Yeah, you use man. But notice in all of these questions, you have 2 variables. We're used to doing x squared plus 6x plus 9 or something. But here, all the variables are multivariables, like as in like you have 2 variables. How do you approach a quadratic, something that has a degree 2 with 2 variables? Turns out nothing changes, okay? You just do it like you would do anything else. So for example, let's look at a tricky one. They're all pretty simple. Let's look at what letters are annoying. Let's look at A. So you have m squared plus 4mn minus 5n squared. This is a quadratic trinomial, okay? Even though there's 2 variables, it's just in disguised form. So how do you factor this? You just do what we've always done. You man it. What do the 2 numbers add up to? What do they multiply to?
They add up to 4 and
Yeah.
multiply to -5.
So what are the numbers?
5 and -1.
5 and -1 would do it. So what do you do next? If you have multivariables, you can't use the shortcut. If you only had x squared or something, then you could have just been like x minus x plus 5, x minus 1. That would be the answer. But here, you have to factor by grouping. What you're going to do every single time is you're going to break down the middle term into these 2. What does that mean? That means 4mn there becomes 5mn minus 1mn. Okay? Gonna break down the middle term into these 2. Why? So that we can factor this by grouping. Factor by grouping means you're gonna factor 2 terms at a time. What can we pull out from the first 2 terms? M, what are we left with?
Plus 5n.
M plus 5n. What can we pull out from the next 2 terms?
N.
Minus n. This sign, if there's a minus, that's always, whatever that sign is, that sign's gonna drop. If there's a plus there, it's gonna drop. If there's a minus there, it's gonna drop. So you can pull out a minus n. What are you left with?
M plus 5n.
M plus 5n. If you do this right every single time, this bracket and this bracket will be exactly the same. Next, you're going to pull out that entire bracket that they both have in common. So 5 plus mn. What are you left with?
M minus n.
M minus n. Therefore, we have factored this. Okay, so the idea is the same. We're going to treat it like a quadratic trinomial. The only difference is there's no shortcut. You have to factor it by grouping it. Cool? All right, let's do one more of these guys. Let's do F. What does it add up to? What does it multiply to? For F.
It adds up to 9, multiplies to 18.
Adds up to +9 or -9?
-9.
-9. It multiplies to positive 18. What are the numbers? There's only two things that multiplies to 18. One of them is 9 and
-3 and -6.
yeah, -3 and -6. Now you're gonna do the same thing here. You're gonna break down the middle term into what? What do we rewrite this as? Everything else is gonna stay the same.
You have the -6 and -3.
Yes, it's gonna be -6 PQ minus
Mhm.
3 PQ, because -6 PQ minus 3 PQ is -9 PQ. Now you're gonna factor this by grouping. From the first two, I'll give this to you. You can pull out a 6P. You're left with 3P minus Q. What's the next step here? What can we pull out from the next two terms?
-Q.
Negative Q, yeah. And what are you left with?
3P minus Q.
Yeah, 3P minus Q. These two brackets will always be exactly the same as long as these things work out. Next, you're going to pull out that bracket, and then you're going to be left with 3P minus Q like that. And that's the end of the question, okay?
Mhm.
This is arbitrary, but what are the x-intercepts of this? So the question would be like, what are the x-intercepts of f? How do you do this? Look at this. We have it in factored form, right? I'm going to
You set
assume,
it to 0.
yeah, you set it to 0, and I'm going to assume by x-intercepts p-intercepts. So 3p minus q is equals to 0, 3p is equals to q, p is equals to q over 3, and 6p minus q is equals to 0. P would be q over 6. So those three are going to be your p-intercepts in this case, okay?
Mhm.
What happens is when you have multiple variables, your x and y intercepts are gonna depend on each other. If it's a two-dimensional thing, x and y, then you have this. If it's just like y equals x squared plus 6x plus 9 or something, then you'll have a x-intercept there, y-intercept there, like that. But if you have multivariable in your quadratic equation from the beginning, this means you're going to have to give it a new variable for the equation. And that is going to be z. Now, this is beyond the scope of this course, but what that means is instead of getting a two-dimensional diagram, you get a three-dimensional diagram, which looks like this. This is the z-axis, this is the x-axis, this is the y-axis. The graph of that, I don't know what it looks like. It's very difficult to visualize, but I would assume it would look, so what do we have? We have a quadratic, right? It'll be like a semi-sphere in 3 dimensions. Something like this. Okay?
Mhm.
That's what it would, I think that's what it would look like. It's probably gonna be facing up because it's positive. So not like this, but this thing's upper half like that. I think that's what it will look like. So the x-intercepts, the point being the x-intercepts are going to be dependent upon the y-intercepts or the y values. You're not going to get p is equals to 3 or something like that. Let's move on to this one. So Paul says if you can factor this expression, anything in this form, you can factor anything in that, or the same thing with a plus sign in the middle. Can you think of an example where this equation is true? Give me a value of b and c. I'll give you one of them. X squared minus 8x, okay? where 8 splits up into maybe 4 and 4, negative 4 and negative 4. So that's what it adds up to, and it multiplies to 16. So that would be one example. Where B is 8, I'm comparing this with this, where B is 8 and C is negative 16. What could be another example? What about this one, 5x? Where 5, I'm splitting this up to negative 2 and negative 3. What's gonna be the C value? What are they gonna multiply to? They multiply to positive 6, yeah?
Mm-hmm.
And let's try one more. X squared minus 10x, where 10, I'm splitting this up into anything I want to, basically. Negative 5, negative 5. What's gonna be the C value?
10.
No, 25. Negative 5 times negative 5. Let's try one more. X squared minus 12x. Let's say it's negative 10 and negative 2. What does it multiply to?
20.
20, okay? So there's an infinite number of these examples. We can just work with one of them. So we have x squared minus negative 8x plus 16. We know this is, if you man this, you're gonna get x minus 4 because the two numbers are negative 4 and negative 4. Alrighty, so we can factor this. What if we do the same thing with a positive sign in the middle? X squared plus 8x plus 16. Maybe for the purposes of this question, we're gonna give that a negative sign as well. So maybe that example isn't the best. So I'm thinking of x squared minus 6x. Let's make this 8 and minus 2. What does that multiply to?
Negative 16.
Negative 16. So if you man this, you're gonna get x plus 8, x minus 2. So now this is in the form of this, or both the b and the c, they have a negative sign in the front. So now let's rewrite it in this form. What does it become? Compare this with this, right? We had both negative signs before, but now one of them is positive. So what's our new equation?
Plus 6.
Yeah, plus 6x minus 16, like that. So now let's see if this is factorable. M-A-N, what does it multiply to?
16. Negative 16.
16. It adds up to negative 6, oh sorry, positive 6. What are the numbers?
8 and negative 2.
8 and negative 2. So can you factor this? What's the answer to this question? Is it a yes or a no?
Yes.
Yeah, it's an yes. So yeah, we agree because it works, right? You can give them a few examples if you would like. Cool.
Mm-hmm.
Um, that's it for that. Let's go down here. Again, the goal is to factor them. What's the degree here? What's the power? Degree just means power, maximum power.
4.
4, right? So now this is not a quadratic, but there's still the trinomial. It's still a quadratic trinomial. It's in the form of a quadratic trinomial. What do we do in this case? Just like we did with the XY thing when we had multiple variables, nothing really changes, okay? You're gonna approach this the same way, or at least try to approach it the same way. We're looking for two numbers. When we add them up, we're gonna get positive 6. When we multiply them, we get negative 27. What are the numbers?
9 and -3.
9 and -3 would do it. So now look at this. Again, like we did at any other question, we are going to split that middle guy into 9x squared minus 3x squared minus 27. What can we pull out from the first two terms?
X squared.
Yeah, you can pull out an x squared. What are you left with?
X squared plus 9.
X squared plus 9 is right. What can I pull out from the next two?
-3.
What are you left with?
X squared plus 9.
Think about it again. You're pulling -3 out of -27. Is it going to be plus 9 or minus 9? It's going to be plus 9. You're right. Yeah. I don't know why I thought it was minus 9. Yeah, and we're pretty much done because you can pull out that bracket. X squared minus 3. Can we factor either one of these further? We could, but we don't have to. This is in a semi form of difference of squares. What you could do with that, remember, for difference of squares, you're just gonna square root it. The square root of root 3 is root 3. So you can do x plus that, x minus that. Okay? With this last step, I don't think is necessary because that's not a whole number. If it was a whole number, then you would have to do it. Otherwise, you wouldn't get full marks, but it's not. So this one, take it or leave it. How do we do this? Now, this is not a quadratic. There's multiple variables. Does anything change? Does our process change? It does not. So we're just gonna do the same thing we've been doing. The only thing is, whenever you're trying to factor something, if in the very first step, if you can pull something out, always pull something out because it's gonna make our life easier. Here, what can we pull out?
-4.
Yeah, we can pull out a -4. So you're left with m4 minus 16, m2, and 2 minus 20 and 4. That is completely wrong. It's gonna be minus 4 m squared n squared minus 5 and 4. That one is right. All right. So we pulled out -4. What do our things multiply to? What does it add up to? Again, notice it's not a quadratic, it's a quartic. Quartic means degree 4, but it's in the right form, right? It's in the right form, which probably means we can factor this, or at least we can try to, as long as we get the right numbers. What does it multiply to? What does it add up to?
It multiplies to -5.
Yeah, adds up
Adds
to
up to -4.
what are the numbers?
-5 and 1.
Yeah, -5 and +1. And what you're going to do is you're going to break down. It's always going to be the central guy, the central term here. That you're going to break down into those two. So -4 becomes -5 plus +1. And then you're going to factor this by grouping. From the first two terms, what can we pull out?
M squared.
I'm going to open a different bracket here, m squared. What are you left with?
-5 n squared.
You need m squared. You're taking m2 out of m4, so m2 minus 5n squared. From the next two terms, what can we pull out?
N squared.
Yeah. What are you left with?
m squared minus 5n squared.
Yes, like that. And then we're gonna pull out this entire bracket. So we have m squared minus 5n squared and m squared plus n squared, like that. And we're pretty much done. This one, again, it's you could, if you wanted to, you could write that as m minus square root of 5n. If you want to use difference of squares, there you go. And that's as far as you can go with this question. And that's it. It does say factor, so I guess this line is kind of necessary because it says factor, and that thing you can definitely factor it, even though it's not a rational number. You can still factor it, so I guess I would advise doing this. And sometimes they will say to the lowest powers possible. That means if you can turn m squared into m, then go ahead and do that. I'll just do one of these fractional things. It's not terribly difficult. From the top, I'm going to pull out a 2. From the bottom, I'm also going to pull out a 2 because I can. That's the only thing I can pull out. And I always do this every single time. So this 2 goes with this 2. Look at the numerator there. It adds up to negative 12. It multiplies to 32 positive. What are the two numbers? So it multiplies to positive 32, adds to negative 12. What are the numbers? One of them is negative 8.
And negative 4.
Yeah, negative 4. Here we have, there's some multiple variables thing going on. The a value here is 1, so we can just use the shortcut to factor this numerator. It's going to be x minus 8, x minus 4. X minus 8 cancels out with x minus 8. That means you're going to get x minus 4 as your final answer for this question. X minus 4 is a straight line that has a slope of 1, y-intercept of minus 4. So that means is even if you have this thing, this is called a rational function, where you have something in the numerator, something in the denominator, that is simply a disguised linear function. Once you do some algebra, that's just a disguised straight line. So if you plot it on Desmos, this entire thing, if you throw it on a graphing calculator, you'll just get a straight line like that. Okay, even though it looks weird and complicated, it's just a straight line, turns out. Technically, there will be something called a hole when x is 8. And the x value is 8, because if x were to be 8, you'd get a 0 in the denominator. So you're gonna get a hole there, which is a literal hole in the graph. It can be 7.99999. It can be 8.00001, but x cannot be exactly 8. Because if it were exactly 8, then you'd get 0 in the denominator, because 16 minus 16 is a 0. And you cannot divide by a 0. So that's the deal with these rational functions, it's called, when you have a numerator, when you have a denominator in that form. Most of these questions are pretty redundant. Maybe this one. Maybe we'll do 2 more of these. The question is just factor. What can we pull out from from question B?
4x.
Yeah, you could pull out 4x or you could pull out negative 4x. Then you'd be left with 7x minus. Oh, you can pull out more than an x actually. You can pull out an
4x
x
squared.
squared, yeah. Then you'd be left with 7 minus x, and that's it. You can't really do anything else with that. What about d? What can we pull out?
XY.
Yeah. What are you left with if you pull out an xy?
XY to the power of 3 minus y plus x squared.
Yep. Do you think, is this factorable?
No.
No. And that's it for that question. What about this one? A parabola is defined. Parabola just means a U shape of a quadratic. It just means this. Or it does like a U-turn, you know? Goes here and then completely goes the other way, 180 degrees. So they've given us an equation and it's asking us to find the vertex. How do you find the vertex of a parabola? If they've given you they've given us the equation, right? They're just asking us to find the vertex. Do you remember how to find the vertex?
You find the midpoint.
Well, first you'd have to find the x-intercepts. To find the x-intercepts, you would have to factor it. How do you factor this?
Um,
What can you pull out?
5x.
Yeah, it's pretty simple, right? Then you're left with x minus 3. So what are our x-intercepts?
3.
Yeah, one of them is 3. What's the other one? So you're gonna set this equal to 0, which gave you a 3. You're gonna set this equal to 0 as well. What will that give? If 5x is equals to 0, what's x?
0.
0. So there you go. Those are the two x-intercepts. Which means what's your midpoint? Between 3 and 0.
1.5.
Right. the vertex of a quadratic, we did this last chapter, is called h comma k, okay, hk, where h is the axis of symmetry, which is also the x value of the vertex. So you add them up, you divide by 2, that's 1.5. To find the k value, you would simply plug that back into the equation, the h value, plug it back into the equation as x. And then you want to just plug this in. The answer is negative 11.25. So this graph here has an x-intercept at 3, has an x-intercept at 0. If it has an x-intercept at 0, it automatically has a y-intercept at 0. It's opening upwards, and we know the vertex is at 1.5 and negative 11.25 right there. So this is the graph of this parabola. This line here that goes through 1.5, that's called the axis of symmetry, which cuts the graph in half. What's the equation of that dotted line?
X equals 1.5.
Good. Not gonna waste time with any more factorings. Maybe we'll do one of these cheeky little ones because, this one is interesting. We'll do, I guess we can do these two. All right. Look at B. What do you think the two numbers are? Notice how they've already factored it for you. Okay, I'll give you a hint. These numbers here, those are these two numbers. Those are the numbers that you look at the B value and the C value, what they add up to, what they multiply to, and those are the two numbers. If these two, if 3 and 3 are the numbers, what's the middle guy here, the B value?
6.
Yeah, what's the C value?
9.
9, right? Negative 12 is what they've given us. And sometimes this gets a little bit tricky. Both of our numbers, our ends, are negative, okay?
Mm-hmm.
So what could our ends be? I think there's an infinite number of answers here. Not infinite, but like there's a bunch of right answers. Unlike part B. Part B, there's only one answer, but part C, there's multiple answers.
They could be negative 6 and negative 6.
Yeah, negative 6 and negative 6. So what would they multiply to? What's the C value?
36.
36, exactly. Or you could say negative 8, negative 4, and make that 32. And there's a lot of answers for that question. But there's only one answer for this question. It's way too zoomed in. All right. Here. Adds to negative 7. We know one of the numbers is negative 3. What's the other number?
Negative 4.
Yeah. What do they multiply? What's the C value?
Positive 12.
Positive 12. I'm not going to waste time with these guys. Let's go back to the Cliff question. Maybe we'll just waste time with one of these, or we're going to try and see how to come up with a number. Again, a quadratic trinomial, you can pull out a 2. Now this is where things get interesting because we know it adds up to 7 and it multiplies to 60. What are the numbers? It adds up to a positive number. It multiplies to a negative number. That means your two numbers, one of them is going to be positive. The bigger one is going to be positive. the smaller one is going to be negative. That's the only way it could add up to positive 7, and that's the only way it could multiply to a negative number. Okay?
Mm-hmm.
The bigger number is positive. Think about 60. You can have 2 times 30. That'll never add up to that. Is 60 divisible by 3? Yes, it is. 320. That's also never going to add up to 7. 415. What's the next one? The factors of 60. Is it divisible by 5?
Mm-hmm.
5 times what is 60?
5 times 12.
So what are our numbers?
12 and negative 5.
Yeah, 12 and negative 5. And the a value there is 1. It's just x squared. No extra steps needed. There you go. That's the thing. The x-intercepts are negative 12 and 5. Another rock question. Deanna throws a rock. Okay, that's an equation given. It's a parabola that opens downwards, has a y-intercept of 75. We have no idea where the vertex is. We have no idea where the x-intercept is just yet. The graph looks something like this. How high is the cliff is the first question. What's the answer?
75.
Yeah, 75 meters. Okay, part B. When does a rock reach its maximum height? What are they actually asking us?
The vertex.
So they're asking us for the x and y value of the vertex. Is that what it is?
Mm-hmm.
No, part B is just asking you the time. When, the time. They're simply asking you for h, okay? Part C is asking you for k. Neither question is asking you for both. Part B is asking you for h. Part C is asking you for k. So we need to find the h, which is the midpoint of the x-intercepts, which is the x value of the vertex. So let's go find the x-intercepts for this. How do you find the x-intercepts? Look at the equation. Negative 5t squared plus 10t plus 75. How do we find the x-intercepts here?
You can pull out negative 5.
All right, let's do that. What are you left with if you pull out negative 5?
T squared minus negative, minus 2t.
Mhm.
And then minus 15.
Right, so we know it multiplies to negative 15. It adds up to negative 2. What are the numbers?
Negative 5 and 3.
Negative 5 and positive 3 would do it, yeah. So a value is 1, no multiple variable shenanigans, so it's just gonna be, what does it factor to then? Your two numbers are minus 5 and 3, right? that it just becomes t minus 5, t plus 3.
Okay.
Why does it become that? Because minus 2, you're gonna rewrite that as, this is just, that thing saves you a step, but if you want, you can always do it like this. From the first two, you can pull out a t, you're left with t minus 5. From the next two, you can pull out a 3, you're left with t minus 5. And when you factor it, you get negative 5, t minus 5, t plus 3. Right? Minus 5 plus 3.
Mm-hmm.
If the a value here is 1, then you can use a shortcut. Once you have the numbers, you can straight up do whatever the variable is minus that. So what are our x-intercepts?
5 and negative 3.
Yeah. So therefore, to find the h, which is what part B is asking you, you're going to do 5 plus negative 3 divided by 2, which is 1, right? So 1 second. So that time there is 1 second. That's the answer to part B. How do you find the answer to part C?
You plug h into the equation.
Right. So you plug a, so 1 into the equation becomes negative 5 plus 10 plus 75 becomes 80 meters. So that's the answer to part C. The maximum height is 80 meters. Most of these are whatever we've been doing all this time, nothing complicated. Multiplies to 18, adds up to 11. What are the numbers here? Multiplies to 18, right? Now you gotta start considering the 3 here. Multiplies to 18, adds up to 11. What are the numbers?
9 and 2.
9 and 2. But here you can't use the shortcut because the a value is no longer 1. And you can't pull 3 out. The a value will no longer be 1. So you have to factor it by grouping. What about this one? What does it multiply to? You can't, first of all, notice you can't pull anything out. Because 4 doesn't go into 8, neither does 5. So you're looking for two numbers. What do they multiply to?
Negative 20.
Yeah. What does it add up to?
Negative 8.
What are the numbers?
10 and negative 2.
It should add up to negative 8. So it should be negative 10 and positive 2, okay?
Mm-hmm.
Because it should add up to a negative number. That means the bigger number is going to be negative. So negative 10 and positive 2. Now the a value is no longer 1. No shortcuts. You have to factor this by grouping, which is not terribly difficult. It's just one extra step. You're going to break down the negative 8x into 10x plus 2x minus 2. What can we pull out from the first two terms?
X.
Nope, you can pull out more than x from the first two. Always pull out GCF, otherwise it's not gonna work out. How about 2x? Because 2 goes into both 4 and 10, so it's gonna be 2x.
Mm-hmm.
You're left with what? X minus
5x. Or just 5.
5. What can we pull out? Oh, it should be 2x, because 2x times 2x is 4x. What can we pull out from the next two terms?
Nothing.
So what do we do then, if you can't pull out anything? Does that mean this is unfactorable? Or is there
Can't you
something?
just keep it?
if you can't pull anything out, okay, always pull out a 1. Because you're gonna need the second bracket. And you need both brackets to be the same. So if you can't pull anything out, will happen many times, just pull out a 1. So as long as we need to be in this form for us to pull out that bracket. So you get 2x minus 5, 2x plus 1. And there you go. That's the answer to the question. This one's a little bit tricky because it just is. What does it multiply to? What does it add up to?
It multiplies to 144, adds up to negative 25.
Right. Now, what in the world are the numbers? Look at it this way. If it multiplies to a positive number, yeah, either both numbers have to be positive, either both numbers have to be negative if it multiplies to a positive number. But the fact that our numbers are adding up to a negative number means both of our numbers are negative, okay? Whatever our numbers may be, both of them are negative. Now what with that information? Where do we begin? We know we can't have a positive number, yeah? Which means you can't have anything greater than 25. One of your numbers cannot be 26. One of your numbers cannot be 26, okay? This one's a little bit tricky unless you know your tables. 272, 236, 218, 2933. It's gonna be some combination of these factors. Let me just guess here. It's gonna be 16. 1, 2, 3. I'm just gonna pair these up. So that multiplies to 16, and that multiplies to 9, right? Like that? Does that work? For this question? Yes, it does, right? So there you go. 16, negative 16, and negative 9. Now, what if that didn't work? Then you would kind of want to pair maybe 3 of these together, like 18 and 8, right? Like that. 18 and 8, you want to pair them together. If that doesn't work, you kind of want to pair 4 of these together. 4 times 9, 36 and 4. But we know it cannot be 36. Our number cannot be more than 26, so, or 25, so that one's out. So you can kind of guess and check what your factors should be, right? Or just simply use a calculator. I think that's even quicker, maybe. 144 is either 2 times 72. That's not going to work out. It's 4 times something. You'll see that that also doesn't work out, right? 6, I don't think it's divisible by 6. And then you keep checking, right? Keep checking. So you just do 144 divided by 4. That gives you 36. There's no way our answer is 36 and 9. So 4 is out. 144 divided by 6 is 24. 24 and 6 will never add up to that. So 6 is out as well. What about 8? 8 and 18 does not add up to 25. So that's also out. 10 doesn't work. 12 works, but it's not going to add up to 25. 14 doesn't work, must be 16. So you'd keep checking like that, okay? 8, 12, and you're going to see if 8 times that is that, and if that adds up to negative 25. But here our numbers are negative 6 and negative 16 and negative 9. So sometimes it takes a while to come up with those numbers. So what do we do with that information? We're just going to write it like this. You're going to break down the middle guy. Every single time the A value is 12, or it's more than 1. If this value here is more than 1, you are going to break the central term apart and you're gonna factor by grouping. What can we pull out from the first two terms?
4x.
4x is right. What are you left with?
3x minus 4.
Yeah, 3x minus 4. From the next two terms, what can we pull out?
3
Positive 3 or minus 3?
minus
Yeah. What are we left with?
3x minus 4.
Right. So it's gonna be 4x minus 3, 3x minus 4 as your final answer. Multiplies to negative 42. Adds to 19. What are the numbers? You kind of want to use logic here. If it multiplies to a negative number, adds up to a positive number, that means we have two numbers. Our bigger number must be positive. Our smaller number must be negative, okay?
Mm-hmm.
So start from here. Start from 20 and negative 1. That's out, yeah? Because 20 plus negative 1 is 19, but 20 times negative 1 is not negative 42. And then you're gonna go one up, one down each time. What I mean by that is this, 21 and negative 2. Does that work?
No.
Yes, it does, right? Because that's gonna add up to 19, and when you multiply them, that's gonna be negative 42. So your numbers are 21 and negative 2, okay?
Mm-hmm.
So if one of them is positive, the bigger number is positive, the smaller number is negative, you kind of want to use this approach. Start from 20, negative 1. Well, where does the 20 come from? Just start one step up from 19. So your numbers are 21 and negative 2. From there, it's pretty simple. I'm looking for some big numbers here. Because the biggest numbers are always the trickiest. Let's look at this one. We know it multiplies to 60, it adds up to negative 16. If it multiplies to a positive number, that means either both numbers are positive or both your numbers are negative. But since it's adding up to a negative number, we know both of our numbers must be negative, like that, okay? Negative 16. You can't go more than 16, so you're gonna start here. Negative 15 and negative 1. Does that work? Does that multiply to 60?
Doesn't just 10 and 6 work?
10, yeah, there you go. If you can identify it, that's it. 10 and 6. And that's it. From there, you can figure it out. What about this one then? Pull out a number, if you can. What does it multiply to? What does it add up to?
It multiplies to 39,
Yeah,
adds up to negative 10.
right. So what are the numbers? There's only one thing that multiplies to 39. Actually, did we do that right? No, we didn't, because it was not in the right form. It should multiply to, because they tricked you. You see how the constant became the middle term? We need to switch
Mm-hmm.
places to see the man thing. It should multiply to negative 30. This is in the right form here, and it should add up to 13. What are the numbers? It's 10 and 3, okay? It's negative, actually, does that even work? Did we do this right?
Because then how would it be negative 30 if you multiply 10 and 3?
No, that doesn't work. No, it's not 10 and 3. It's not 10 and 3. One of them should be negative. The bigger number is positive, and the smaller number is negative, because it needs to multiply to a negative number. Now it's a trial and error. 14 and negative 1 doesn't work. What about 15 and negative 2? Does that work?
It does.
Yeah, there you go. Those are your numbers, 15 and negative 2. So that's how sometimes you can decipher what it is, okay? Let me see. Let me give, let's say it multiplies to 168, okay? It adds up to negative, what should we say? 30. Or does that work? Negative, no, it does not. Negative 26, let's say. The question is, how do you find these numbers? These are big numbers, right? And no one knows the table for 18 or whatever, or 22. You're multiplying to a positive number. Both of your numbers are negative. Oh, sorry, you're adding up to a negative number, right?
Mhm.
If you multiply to a positive number, understand that both your numbers either must be positive, positive, or both of them are going to be negative, negative. In this case, we're going to get two negative numbers like that, okay?
Mhm.
And then you want to start like this, 26, negative, negative. You cannot start from 27 and positive 1 because we know our numbers are not going to be positive. So you're going to go down. You're going to check negative 25, negative 1 doesn't work. Negative 24, 2 doesn't work. 23, 3 doesn't work. Negative 20, negative 5 doesn't work, yeah? Now you're getting closer and closer, closer. Negative 15 and negative 10, or sorry, negative 16 and negative 10 doesn't work. Negative 15 and negative 11 doesn't work. And then finally, you'll get to this point, negative 14 and negative 12. Yes, that works. And those are your numbers. That's a way of dealing with numbers that are weird or like weirdly big that you can't kind of do in your head. You got to use logic to see if they're both positive or if one of them is positive, negative. And then from there, you're going to build a table of trial and errors and you'll get it. Eventually you'll get it, okay?
Okay.
Would take a minute. All right, let's call it a day there for today.
Thank you.
Bye-bye.